the cardinal of the set of premise. The set of premise is antibody and bacterium, so the denominator will be 2. Antibody is deducing only for antibody alone is deducing only from antibody. So the support is 1 divided by 2. Bacterium is the same. There are 2 premises and only bacterium allow us to deduce it. So it has half of degree. But fever comes from a bacterium or antibody. So it is 2 divided by 2, that is 1. Eruption only comes from bacterium. So it has degree a half. And in every pre-order with last element, we have that the last element has support 1. So the consequence with different to 1 with greatest support is fever. Has support 1. It is deducing from both premises. Now we want to generalize the definition of support from C less equal to another operator of consequences. For example, we pay attention to the operator C point. C point find consequences that are consequences for a subset of premises. So, following the idea of the operators C less equal, we build the measure counting how many subset of premises support each consequence. And the definition is more or less the same, properties are very similar. The support is the number of subset of premises that allow us to deduce Q divided by the total number of subset of premises minus the empty set. When this definition is possible, if P has at least value 1, is 2 minus 1 is 1, it isn't 0, the denominator. The bigger support a consequence has, the more subset of premise allow deducing it. So it's the same idea as the last definition. And notice that if Q is not a consequence of P, the support will be 0. Well, I didn't say that, but the operator C here has to be a partial operator of consequence. So there doesn't exist any subset of premises allowing to deduce Q. It verifies similar properties. If the subset has only one premise, the support for every consequence is 1. And for all Q that is a consequence of P, the support, when it isn't not less equal, of Q has to be greater than 0. And if the support of a consequence is Q, it means that all subset of premise allow us to deduce Q. Well, support defined in that way is not always a measure. For example, using the little or the infimum operator of consequences is that one that consequences of P are P only. We have an example that there is no element such support of Q is 1. For example, if Q is an element in the preorder, it is that Q is a consequence of P, a consequences of P are P, or support of Q is 0. If we are in this case arbitrary, if the score is 1. But if Q is a consequence of P, it exists any P in P such that P is not equals to Q. Then Q is not a consequence of P because the only consequence of P is P, and the support of Q is not equals to 1. To do this, we have to have a set of premises with more than one premise. Well, but for the operator,
The 1 doesn't have measure 1. The biggest element of the calculator doesn't have
no. Because 1 is because the preorder here can have no 1. If the preorder have 1, yes, 1 always have a support 1. But if we are dealing with another structure that has a less element, we can consider.
Sure that the third line of the first line of the third point, I suppose it should be, if Q belongs to L, then it always exists capital P containing Q. It exists one capital P.
No, the P is fixed.
If Q is in L, Q is not always in P.
No, but we are dealing with a complete set of premises.
I don't know why you
He said
say
the premises is not L.
No, it's P. We have,
Then for each small Q, it should exist some P.
no, but I'm dealing only with one P that has at least more than 2 elements.
And L has
L has whatever.
20.
For example.
Okay. Then not any Q in L belongs to P.
and there is consequences, there are many consequences that
Maybe a
No.
little P.
No, you're working with a consequence operator that is a very stupid one. You say the consequences of P is P.
Only.
Perfect. But I understand in the third point that for each Q in L, you can select a capital P subset.
No, I have a set of premises P.
Yeah, but then L is equal to P.
No.
No.
But why P is equal to consequences of P? I don't see that.
Yeah.
Why P is equal to the consequences of P?
By definition.
By
By definition.
The operator that I'm dealing with is.
She takes the
No, but you mean
Point, let's
is
say P, what P? First point.
This is a definition. This operator is the smallest one.
Yes.
It clearly is an operator of consequences. It's increasing, it's a closure, contains P.
Yeah.
What I doubt is the third point. Because if for all Q in L, Q belongs to P, as P is contained in L, L is contained to P. L and P
No,
are equal.
no. I understand your question. For any Q in L, or either Q is in P or
It's not in P.
is not in P, and if it is not in P, support of Q is 0.
Okay.
But,
Okay.
but if you go back a little bit to the other one that was a measure, because I don't. Yeah, okay. Go to the next slide. Go to the next slide.
This is the last one. You want to see when is a measure or
No, because in the other case, when you have
yes, when I'm working
when you
with,
use with the other support,
yeah.
here you only say that it's a measure for C.